Hey there, folks, and welcome. Today we will be presenting an event discovering possible life on Mars with Derek Detmer from the Seminole State College Planetarium. This project was made possible in part by the Institute of Museum and Library Sciences. Thank you all so much for coming out tonight. I want to introduce our presenter. Tonight we have the director of the Emil Buehler Planetarium and amateur fossil hunter, Derek Detmer. He is set to talk about the possibility of finding life on Mars with perseverance, as well as in other words. If you're just tuning in or you've been paying attention to the news, Derek was just talked about in the Orlando Sentinel yesterday for finding was it a 50-pound, 4-foot mammoth bone, Derek?
That's right. It was a mammoth leg bone, yeah.
Insane. I saw the pictures, and just seeing that in like the Peace River, which I've kayaked and canoed down a few times, just like something like that's that close is awesome. But thank you so much for coming out and talking to us tonight.
Yeah, absolutely. So hello everybody. So as Josh mentioned, so thank you to Josh and Sarah and the other staff at the Orange County Public Library System. Anyways, what I'm going to talk to you about today is kind of a little bit about Perseverance and its mission, what it's doing. And I actually have a little bit of show and tell. I have some rock specimens and some fossil specimens that kind of, hopefully maybe keep our fingers crossed that we may find something like that on Mars. That's kind of the main mission objective of Perseverance. And so what I'm going to do now is I'm going to go ahead and share my screen, and we'll get started here. All right, so let's do that. So I'm going to go ahead and hit this button. And we're going to open up the PowerPoint here. So I'm going to kind of break it into multiple different things here. We're going to mostly focus on this presentation. And I want to talk a little about this mission. So back before Perseverance actually made it to Mars, there was a previous mission called Curiosity. Now, if you were to look at Curiosity and Perseverance from the outside, just the way it looks, its profile, you really wouldn't notice much of a difference between the two. Both Curiosity and Perseverance look a lot alike. They're about the same size. They're both nuclear powered. They do look very identical. However, Perseverance has a massive amount of upgrades, new technologies, and different instruments that it'll be using to actually explore what's going on Mars. And this is a selfie that Perseverance took in its location on Gale Crater. And you can see, now just to give you an idea of size, this thing is about the size of a small car, kind of like a smart car if you think about it, something around that kind of size. And it runs off of nuclear energy. Most of the older rovers on Mars, like Spirit, Opportunity, Sojourner, if you remember that back in the 90s, these rovers were run off of solar energy, but Perseverance and Curiosity, these are nuclear, and that makes them more self-sustainable. Obviously, they don't need to depend on the Martian sunlight. Of course, with Martian dust blowing all over the place, these solar panels become less and less effective. So having nuclear energy, it provides more reliable energy for these rovers. So it's really cool here. So we're going to talk a little bit about some of the technology that that Perseverance has. So it has many different types of camera sensors, both invisible, infrared. It's looking for heat signatures. It's looking for various different layers. It actually has radio signatures. So you can actually pierce down below the surface of where it is and look for those different layers of rocks that are very important for us to see. It also contains a SuperCam mass unit that actually allows to hear Mars. And later on, I'm actually going to play a sound clip of wind on Mars. I know, there's not a whole lot of wind on Mars, but at least, hey, you get to hear a sound from another planet, which is really, really cool. It also contains several other cameras, other types of sensors, calibration instruments. And one of the coolest things that just recently was used was this thing called MOXIE. Now, MOXIE, its purpose is to take the carbon dioxide in the Martian atmosphere and convert that into oxygen, breathable oxygen. Now, probably what you might be thinking right now is the fact that, well, if we can take in that carbon dioxide, which pretty much Mars' atmosphere is made up of, it's a very thin atmosphere, but the atmosphere that Mars does have is mostly carbon dioxide. And think about this, if we're able to take that carbon dioxide and convert that into oxygen, who could use that? Well, potential human astronauts that will eventually head to Mars sometime in the future. So the technology that's being experimented on Perseverance will eventually help astronauts and other astronauts, not only on Mars but in other areas that potentially have carbon dioxide, and use that to breathe and to. So this is a really, really exciting experiment, and it did its first successful mission. It was able to convert that carbon dioxide to oxygen recently, and so this is I guess at this point, mission success, but it will also continue doing that, make sure that it continues to run and it's able to produce that oxygen where needed. So these are kind of, I don't want to go into all the details of all the instrumentations, but either way, the big picture that you want to know is that it has the ability to see underground, it has the ability to detect things, it has the ability to see not only invisible light, but in other wavelengths of light as well. And it also contains instruments, which we'll talk about later on, to actually chemically study the samples that it's going to take. And of course, the primary mission of Mars 2020 or Perseverance is to find that sign of ancient life on Mars. Now, I want to talk a little bit about some of the cool things that that happened. So, if you all remember, a couple of years ago, there was the Mars Mars opposition, and that was actually last year. And the Mars opposition in 2020, around in the summertime, was kind of where we needed to take this spacecraft and head to Mars. Before it did that, of course, we all know 2020. Some of us forget 2020. Some of us think that 2020 didn't exist because of how crazy 2020 was. But 2020 did have some amazing stuff in terms of astronomy. We had this very successful launch and flight to Mars. We also had a visible comet Neowise, which I thought was incredible. So even though there was a lot of stuff about 2020 that was really, really, forgettable and really terrible, we also did have some cool things that happened last year that we cannot forget about. And one of the things that Perseverance that was attached to the spacecraft was two plaques. The one on the left here, as you can see, is honoring the healthcare workers during the COVID-19 pandemic. You can see the caduceus with the planet Earth. Caduceus is that universal medical symbol, right? And then off to the right, which was really neat, is I think it was a couple of years ago, you actually could submit your name and you would get this cool passport to Mars thing. And this has a little digital chip in there that actually contains all the names of people who actually submitted that. So technically, if you submitted your name to this program, your name is now officially on Mars. So you can brag to your friends and family and say, hey, I'm on Mars. Well, not physically, but my name is on Mars, which is really cool. So again, two different things that were really neat that were attached to this, including the workers for the pandemic and honor that, and as well as sending those names that people, any person could submit their name, those kind of things there. So I'm sure there's a bunch of ridiculous names. I don't know if NASA employees have the ability to filter out, so I'm sure there's a bunch of funny names in there, so if we do find ancient life or even intelligent life today, they're going to go there and they're going to see probably 90% of them are just ridiculous names like Darth Vader and all that stuff. But I'm sure there was a filtration thing on that. But I think it's kind of funny to think that there probably are some really questionable and funny names on that list. So what I'm going to talk about right now is kind of the mission overview of Perseverance. So back in July 30th, actually me and my colleague who worked at the Planetarium at the time, we got a chance to actually see this launch. And so as you can see here on the little animation here, you can see the launch of this Atlas V rocket. So the Atlas V rocket was the payload rocket that was used to send Perseverance into space. Again, this occurred on July 30th. It was actually originally scrubbed for the original launch date, and it was postponed to very close to what we call the launch window. Launch window is the length of time you have in which basically you can successfully launch this thing, because everything's moving in space. Earth's moving, Mars is moving, the rocket's moving, and everything needs to line up. No pun intended. Everything needs to line up to get properly placed, so that way this rocket can make its way to Mars and not miss it. So that launch window was getting close, but they were able to successfully launch it. And I can say it was an incredible opportunity to be at Kennedy Space Center, to watch this launch, to see Perseverance make its way to the red planet Mars. So that was really cool there. So first part, launch. And before the launch, they had to do all kinds of different experiments on the spacecraft. They had to put it in acoustic chambers and make sure that it can withstand the intense sounds and vibrations from the rocket. It also had to be sterilized, make sure there's no, well, if we're looking for life on Mars, we don't want to bring our life to Mars and accidentally think it's life on Mars. So it had to be fully sterilized, and all this other stuff needed to make sure that the spacecraft was ready to go. The next thing is to cruise to Mars. So essentially, it spent about 7 months basically falling into orbit towards Mars, and it did arrive on Mars on February 18th. February 18th on 2021, and at that point, we move into what we call the entry, descent, and landing. Now, this was the 7 minutes of terror for those that are with the mission control, because at that point, the time delay between communication between the spacecraft and here on Earth is in such a way where the spacecraft will actually make it to the ground before it actually tells it that it made it to the ground. So there's no mistakes. Everything had to be pre-programmed in order to officially make its way down. And of course, obviously, we saw an earlier picture of the selfie of Perseverance. It successfully landed. It was incredible seeing everybody, cheer for joy. It was a really cool thing to watch. They did a full live stream on that, so it was really neat to see that. So it was successfully descended and landed. It actually was done in this very elaborate, what we call sky crane. This thing is so heavy. Back in the day, the early rovers on Mars could actually land basically using a bunch of balloons. They inflated all these air balloons, and like a beach ball, it literally bounced off the surface of Mars and slowly made its way down. This thing can't do that. So what it does is that just at the point, just maybe a couple hundred feet above the surface of Mars, this sky crane shoots off retro jets and slows it down to the point where it could just literally drop it nice and neat on the surface. And it did, and it was incredible. So we had that done. That occurred in February of this year. And now we are in the surface mission phase. And right now, the qualified lifetime of Perseverance is about 1.5 Mars years. That's about twice our year, or closer to three years or so. So what it's going to do now is it's going to literally spend the next couple of years on Mars, and maybe more. A lot of these rovers on Mars last a lot longer than they're usually planned for. Spirit Opportunity lasted for a very long time, 7-8 years before it was just not usable anymore. So hopefully we'll be able to use this spacecraft or this rover for a very long time. And in this time, now we're in this period where we are just right now at this point, Perseverance is really just kind of checking its instrumentations, listening for things. I'll show you in just a minute here. We had the success of a companion to Perseverance called Ingenuity. That was a successful flight. So we're starting to kind of now slowly start moving our way into actually doing what this mission is supposed to be doing. So this is kind of where we're at right now. We're in kind of the surface, beginnings of surface, making sure everything works right, making sure everything, all the cameras work, all the sensors work, everything works before we start getting really excited to go and explore this area of Mars. So here's some of the mission objectives, kind of give you a little bit of a sense of the different mission objectives here. We have some geology. We're going to obviously explore this area called Jezero Crater. This is an ancient lake bed, impact crater, ancient river delta, and it contains a lot of minerals and different things that could be prohibitive for life. We're going to look at astrobiology. We're going to sample stuff. We're actually going to be, the coolest part about this mission is that Perseverance is actually going to take core samples of various areas in this area, and it's going to store them and deposit them in different areas on Mars. And later missions will actually pick up those samples and will return them to Earth. So the eventual hope is that the material that Perseverance finds that we really like, we want to keep, we're going to bring that to Earth, and we're going to have actual Martian rocks and potentially fossils on Earth that astrobiologists, planetary scientists, astronomers, scientists can really explore here on Earth, can do the really good science that unfortunately Perseverance is limited on what it can do. But we bring that stuff back to Earth. Scientists can really scrutinize, can really look at that material. And now, of course, the other thing too is I told you earlier about Moxie. We're also preparing for humans. So a lot of again, we're trying to learn more about the environments in this area, this could be a good place for humans to land, and also using that experiment Moxie to convert carbon dioxide to oxygen. So a lot of really cool things that we're doing in this program here. So this is kind of a little schematic showing the sample system, if you will. So again, Perseverance is a genuine geologist. It's literally going to drill into the Earth, or in this case, into the Mars, and collect various different samples of rocks and dust and maybe potentially fossil material, and actually store that, as you can see here on the top right, different sample tubes. Now, those sample tubes will be deposited on the surface of Mars and get collected by a future mission. Right now, the future mission is hoping to get there either between 2026 to 2030. That's kind of the time frame. There really isn't a hard date yet on when that's happening, but hopefully it will happen very soon. So it's really cool that we're going to get actual Martian rocks from this rover here to Earth, which is really cool. And this is kind of a closer up image. It kind of looks like a lightsaber. All right, it kind of does look like a lightsaber. Happy May 4th, by the way, for all you Star Wars fans. I'm actually wearing a Obi-Wan t-shirt today in honor of, and this actually kind of looks like Obi-Wan's lightsaber from Episode 1. So you can just see how much of a nerd I am. But these are essentially the different core samples. You can see kind of the core samples that are being used. We're going to break them up into different layers. And again, those are going to be brought to Earth, and those are going to be really investigated. So we can learn more about the geology, history, all the things that we want to know about Mars. So the landing site, why did we land this thing in this area? Well, here's a map of Mars, and Mars has a lot of really cool geology. We know that Mars once was a much more geologically active planet. It had volcanoes, like you can see here. This is called the Tharsis region, which is actually an area, a very high plateau, where we have very large volcanoes called the Tharsis Mountains. We have Olympus Mons, another huge volcano. Again, this plateau is very high up, and actually we have a rift valley here called the Valles Marineris. And a lot of this would have most likely been essentially ocean at the time of ancient Mars. We knew that Mars now, based on previous missions like Curiosity, we know that Mars did have liquid water. We know that because we see the presence of clays, which usually suggests liquid water. We see water erosion on the shores of what we would see where the water would have been. We have lots and lots of evidence of water on Mars. We see ancient riverbeds, which is actually where Jezero Crater is. Jezero Crater, which is the landing site, which you see here, is actually located in an area where there is an ancient riverbed on Mars. So again, Mars was a wetter, hotter planet. The problem, though, is that one of the missions called MAVEN detected things called proton auroras, which is basically the sun releases a huge stream of particles into the solar system called the solar wind. Well, the solar wind slowly reacts with the atmosphere of Mars, stripping the atmosphere of Mars away, kind of like a sandpaper. Sandpaper kind of slowly breaks down the what we call the superficial, the top layer, right? Well, over time, millions, hundreds of millions of years or so, that atmosphere withers away, and we actually have evidence of the solar wind reacting with the essentially leftover atmosphere of Mars. So there's scientific evidence now showing that Mars is losing its atmosphere. So most likely, at some point in history, Mars was much more Earth-like, but due to the loss of its atmosphere, it pretty much is now the way it is today. There is water on Mars. It's frozen water. And actually, if you dig deep enough, eventually you get to a permanently frozen layer, and we find deposits of water ice all over in different areas on Mars, including the ice caps, which are actually the ice is buried under a layer of frozen carbon dioxide we call dry ice here on Earth. You've probably been to Publix and gotten some dry ice from your, for a science experiment or for a fun birthday party or something like that. So anyway, so this is kind of the setup here of Mars. So Jezero Crater is the site of this area. So we're going to zoom in here. And it's actually in the area known as Syrtis Major. It's actually an ancient lava basin. We're actually going to go even closer. And this is the site of essentially where Perseverance is. And you can actually see right here, you can see the water flow that would have essentially dumped water into this area right here on Mars. Now, if you were to look at satellite imagery on Earth, you would see, if you were to look at the Amazon River Basin, if you were to look at any major large river, you would see this outflow of fresh water into an ocean. And essentially that's what's happening here. You're essentially seeing fresh water that was probably dumped into either more fresh water or maybe possibly salt water. And when you look at, like, say, the Amazon, for example, the Amazon, dissolves clays, it dissolves lime rock, it dissolves organic material, decaying leaves or plant material or even animal material, and that slowly trickles down into the ocean and basically is deposited. You can actually see all that mineral, all that stuff being dumped into the Amazon basin. Go on Google Maps and go down to the Amazon basin, and you can actually see the difference between freshwater and saltwater. And even places like Tampa Bay, the Hillsborough River and the Alafaya rivers, they dump a bunch of fresh water at times, which we have big, strong storms. Places down, we talk about the Peace River with fossils. That area eventually empties out into the Gulf of Mexico, and that releases a ton of nutrients as well, which actually drive like algae blooms. So these are areas where we think there could have been blooms of ancient life. There could have been algae, there could have been microbes, there could have been things that were starting to develop in this area, which explains one of the reasons why we chose this site as the prime site for finding potential life on Mars. So that's kind of the real place why we wanted to do this. This is a primo place for finding those remnants of ancient life. And what I'm going to show you all later on here are actually various fossils I have collected over my life. As Josh mentioned at the beginning, I am an amateur paleontologist, fossil hunter, and it's a hobby I enjoy. But by including this kind of fossil stuff, it allows me to better understand what's going on with Perseverance and what we want to look for. So I have some different samples of different things that could potentially Perseverance may find. One of the last and latest, coolest things that occurred during the Perseverance mission right now is essentially the flight of Ingenuity. Now, Ingenuity is this little tiny solar-powered drone that and you can see here in this animation here, you can actually see it slowly hover over the surface of Mars. This is the first time ever in history we have launched or flown something on another planet. Of course, in the early 1900s, we have the flight of the Wright brothers at Kitty Hawk. Now, 2021, we have the flight of Ingenuity on Mars. I think this is incredible. And the question is, what's the purpose of Ingenuity? Well, Ingenuity is going to be a scout. Ingenuity is going to look for areas that could essentially help Perseverance go. Instead of just blindly moving around like the other rovers have done, they just kind of wandered around and whatever. This drone is going to survey different areas and go, that looks really good. We're going to spend our time over there. So that's kind of the purpose of Ingenuity. Ingenuity is going to be the scout that's going to look for those areas that are really, really nice, and also help Perseverance find potential obstacles. There, hey, Perseverance, there's a big crevasse, or there's a big hill that's just really, really steep. Don't go that way. These are things that will help and make the scientific mission more successful, because you don't just have to just drive around. It makes it easier for the scientists to operate. Which, by the way, Perseverance isn't like a Wall-E where it could think. It's not that smart. It does rely on commands sent to it. It has a little bit of autonomy. It can kind of while it's moving around, it can go, okay, there's an obstacle here, move here, and all that. But it does need commands. It does need to be told, go this way. We're going to head this way. So it does need that. And so that communication between Ingenuity and Perseverance is going to become really, really super cool. Now, one of the things I want to show you all, actually not show you, I'm going to let you hear it, is I actually have one of the technologies of Perseverance is the ability to hear sound on Mars, which is really, really cool. And what I'm going to do now is I'm going to go ahead and let me see if I can hopefully share this. So I'm going to try that. Hopefully it works. And that's right. I gotta bring it up here. There we go. I am going to share this, just a Google Chrome thing here. And what you're going to hear right now is you're going to hear literally the sounds of Mars. Now, at this time, what I like you to do is close your eyes. Think of yourself sitting on Mars and just imagine this sound that you hear. So I'm going to play it right now. So as you can see here, essentially we are we heard the sounds on Mars, and there is a wind on Mars, and the wind on Mars is not as strong as Earth because it doesn't have a dense enough atmosphere. In fact, one of my pet peeves of The Martian is the fact that in the beginning of the movie there's this massive windstorm that causes all this disarray, right? The problem is you can't actually have that on Mars. The wind, even 100-mile-an-hour wind, would barely have enough force to push a plastic bag, let alone destroy satellites and throw people around and all that. That just wouldn't happen on Mars. So the wind, this was obviously amplified. There is wind. There's tornadoes on Mars. There's actually dirt devils on Mars. There's snowstorms. Actually, it snows frozen dry ice in the Arctic or the polar regions on Mars. So there actually is a lot of weather on Mars, which is actually really neat. It's not just this barren desert with nothingness. It actually does contain snows. It has winds. It has dust storms, really bad dust storms. There's been several times that people like me who want to show people Mars through a telescope, the surface of Mars would be completely obscured by the dust from these dust storms, because actually the wind would essentially create almost like a baby powder. Imagine having baby powder on a table and you hit it, you whack it, or you blow it. you blow it, and all of a sudden it just kind of becomes very it's suspended in the air. It's kind of what happens with the Martian dust. So you get these really interesting things that happen on Mars too. So hopefully Perseverance will be able to capture more sounds with these kind of different things. So now what I want to show you here is I want to show you some rocks again I've collected. This is actually a polished one. This right here, hopefully it kind of shows up. Yeah, it's a little. Hopefully that shows up here. So this right here, it doesn't look like much. This is actually called a Butterstone. There we go. I was trying to remember what it is. This is Butterstone. Now, what this actually is this is the byproduct of ancient bacteria that lived about 2 billion years on our planet. Now, what happened here is a bacteria, oh, there we go, a bacteria called cyanobacteria was behaving a lot like plants. It was actually using photosynthesis. It was collecting the carbon dioxide in our atmosphere. It was converting oxygen, and one of the byproducts was the production of this rocky mineral here, which is mostly like a carbonic or carbonate type material mineral here. And the byproduct of this is called a stromatolite. Now, the stromatolites are formed from bacteria. So this right here, this Butterstone, is essentially produced from ancient bacteria. So Perseverance could potentially uncover something like this, and it has instrumentations to analyze the mineral and you can see how it kind of created various layers. That's because as the bacteria grew and developed, it deposited more and more. It's kind of like a cake over time. So you have these various layers here. And so this, again, is the byproduct of ancient life. And so hopefully Perseverance may find something very similar to this on Mars. This is probably, if I were to say, probably the most realistic thing that Perseverance will find. It will find this. It will find a stromatolite. It will find this kind of stuff on Mars. But if we get extremely lucky, we may find trace fossils. Now, this is a fossil that I collected in Georgia. If you look closely, you might be able to see it right there in the middle there. That is a trilobite. So this is about 500 million years old. And this is a trace. Basically, the trilobite died in the mud, kind of like a muddy, salt tidal pool kind of thing. And it created a cast. It kind of like when you take something and you cover it with, a clay or something, it creates a cast, right? Well, that's exactly what happened here. Will Perseverance find a cast of some form of ancient life? Now, we found casts of bacteria, and we found actually kind of like when you look at a petri dish, you can actually see the trails left by bacteria. We found things like that here on Earth as well. Bacteria that also move around could also leave deposits of other things too on the surface of Mars. So this could also be another type of fossil or evidence of ancient life on Mars. So again, this is kind of one of those things that could potentially be found on Mars. The last thing I wanted to show you is this right here. This is actually, if you look closely, you can see what are things called brachiopods. These are basically kind of like gastropods, like seashells, but their shape is more mirrored. They have a different type of a unique shape to them. There's also little corals, like ancient corals. This is about a 350 million year old specimen. This was actually collected in Missouri, just west of St. Louis, right off of an interstate cut. So over time, interstates, they have to cut through rock to build the highway. And some of these road cuts actually have fossils and rocks. So next time you go on a road trip, if you see a really cool road cut, maybe stop there for a second and see if you find any cool things. You might find some fossils or some rocks. But anyways, right here, these are true fossils. These are ancient life that has been mineralized. And in this case, it's been mineralized by the mineral silica. So this has been silicified, or it turned into silica. And this is the leftover remnants of that. So could possibly Perseverance find ancient life like this. It's actually preserved in the rock. This is probably going to be the hardest form of fossil that Perseverance will find. Fossils here on Earth are actually pretty incredibly rare. Even though we find lots of fossils, there's only certain areas on the Earth's surface that actually fossils form. Most of the time, they're either destroyed or the chemical composition is just not there to produce a fossil. So finding that kind of fossil will be very, very tough on Mars. I think that the one that we're going to find is the stromatolite kind of stuff, the stuff that's the byproducts of life. Certain crystals grow because of the release of organic material. So I think that what we're going to probably most likely look for on Mars is what we call biosignatures. Life forms that existed either released some type of chemical or something that was deposited in the geology of the planet, and it can only form because of life being there. I think that is the more realistic thing that Perseverance is going to find. If it finds fossils like we saw with those brachiopods and corals, that's going to be unbelievable. And I hope we can find something like that. But, I like to keep my expectations low, but my excitement high. So hopefully we'll find something very, very neat on Mars very soon. And this mission is going to go on for several years, so it's going to take a while for them to get to that point. But there's the possibility of ancient life that once existed on Mars. Now, the next interesting step would be, could have life evolved to deal with the conditions on Mars? For example, what if life adapted on the surface first, but because of of climate change and the change on Mars, what if life actually slowly crept down into that ice and it evolved to live underground? That's the next step. Could there possibly be life on another planet that can be found underground? And another planet, or not really a planet, a moon around the planet Jupiter called Europa, could very likely have life underneath the surface. And what we think there is a liquid ocean underneath the surface of Europa. So I think in the next 50 years, we're going to have a much better chance of finding life on another world than we had in the last 50 years. And now when we think of life, we're not talking about life like us. We're talking about, again, bacteria, small single-celled organisms, maybe advanced life like corals and sponges and things like that. But I don't think we're going to get to that point where we have animals and very complex plants and things like that existing on Mars. But science is all about surprises, right? What we know now will change in the next 10 years. So who knows? There have been a lot of surprises. One of the biggest surprises in the last 50 years was the finding of water in places like Mercury that once thought water couldn't exist. And now we found water deposits in the northern region and polar regions of Mercury where there's no sunlight. So again, there are lots of surprises, and who knows what will happen in the future. So, but that's pretty much all I have for today for my presentation. I probably would have a lot more if Perseverance were longevity, but I wanted to really talk about the importance of this mission, what it's looking for. Eventually, it's going to help us better become geologists in the future. Humans going there, we'll have a better idea of how to investigate and all that. So anyways, what I'm going to do now is if we have any questions, this is my favorite part of the program is just entertaining questions from you all. So if anyone has any questions, this is my favorite time. So thank you so much for listening, and I'm looking forward to hearing from you.
Sorry, I think I was muted that whole time. Thank you, Melanie, in the chat for that. But yeah, thank you so much for coming out tonight. That was fascinating. I love hearing about space and getting excited about what we're actually doing out there. It's really cool, and the potential is always awesome. Now we had a couple questions already here. Ale asks, what part of the body is the fossil? Either specifically towards the fossil that you showed or other ones that we might find.
Yeah, that's a good question. So, like for example, the mammoth bone that I found with my friend the other day. Usually, fossils form from highly mineralized things in the body. For example, bone. Bone is predominantly calcium, right? So it's gonna it's gonna mineralize from that, right? So in this case of this fossil here, again, so this was originally calcium carbonate, just like any other shell on Earth, right? Well, over time, silica deposits were basically so this is either submerged in water. Obviously, it's an ocean, but there were silica deposits from maybe runoff from a river or something like that, and slowly the calcium carbonate dissolved, and the silica replaced it at the same time. So usually, in order for a fossil to form, you have to have a previous mineral that it could either replace it or increase the mineralization, if you will. So again, now trace fossils like this. Trace fossils could literally create the outline of anything. For example, dinosaur fossils, we've actually seen imprints of skin or scales from mud. Trace fossils actually create imprints of feathers, not the feathers themselves, but imprints, kind of like, if you put your hand in that mud, you could potentially get the wrinkles in your hand or whatever, or maybe if I like hit my head, you could see imprints of my beard, So you could then say, hey, these animals had fur on their face, So that's kind of what when we're looking now. Again, with the stromatolite, that's the byproduct of a life form. So that's basically their excrement, if you will. So in a way, we're kind of looking for alien poo, but not in the same way that you think of. So, so there's different forms of what we would consider fossils. But again, this is probably the most likely candidate because of the fact that if the ancient life existed, it could have replaced something or left some deposits, kind of like corals, right? When you go to a place and you see corals, and that coral, is the exoskeleton. It's not the actual coral. So that's the byproduct of the coral. So that's kind of what we want to look for.
Very cool. Yeah, it's crazy how much stuff can be left behind, just like just through geology, like learning all that stuff, and actually that kind of like leads into the next question. I don't know exactly the context. If you want to elaborate, feel free. But this person was asking about carbon dating, and I guess if Perseverance is performing that, or how that's going to work.
So carbon dating is a form of what's called radioisometric dating. There's actually different forms. Carbon dating is the more famous one because a lot of people learn that in school from dating like prehistoric human remains. But carbon dating only really works for about 5,000 years onward. We're talking probably hundreds of millions of years, maybe even billions of years in time. So there are different atoms that what we call have half-life. So imagine an atom, and over time the atom slowly breaks down just naturally, just breaks down. And it will slowly turn into a different type of atom. And so the ratio of the original atom and what's left over, or the byproduct of that atom, the ratio of that will tell you how old. Now, scientists have done lots of experiments and scientific research to find out what the half-life of all these chemicals are, not chemicals, atoms are, elements are. And what we can do then is to say, well, if we look at the rock, we find out there's this much material in there, then we can get an idea of the age. So in a way, if, for example, we do find out that this thing is only 3,000 years old, has a lot of carbon in it, we could potentially use carbon dating and find out the life is actually younger than we thought. But chances are that's probably not going to happen. But we're using a form of dating, which is called radioisometric dating, which is what carbon dating is part of. It's just one of many different things that we use. We use uranium, we use iron, we use all kinds of different elements for dating.
Neat. Yeah, it's crazy to know know all that. It's awesome. I had a question actually that I was thinking about when you were talking about the Ingenuity kind of flying off and scouting out. How is it doing that with the difference in like the atmosphere and in terms of wind? How is it like propelled and moving around?
So that was the true ingenuity of it all, right? That
Nice.
can't help it. Sometimes it just
I got it. It's right there.
Um, um, these blades are made up of carbon fibers, so they got to spin real fast to create thrust just to get up. Because you're talking a third of the atmosphere of Earth, and the higher you go, the less atmosphere. It's the densest part of the atmosphere is actually from your knees down on Mars, and then after that, it gets really thin real quick. So the higher it goes, the faster these propellers are going to move. These are very long propellers. There's multiple ones, and they're rotating very fast. Extremely fast. I think it's like 4,000 revolutions a minute, some ridiculous number. I mean, it's just really, really fast. I think it's not. I have to correct. I have to look it up again on the exact speed. I'm not sure 100% on but it's a very, very fast rotating speed. That in order for them to actually get this thing to actually lift up. So it's incredibly amazing. The engineering, and this is again, kind of like the very first airplane, right? Eventually we're going to use this technology on other worlds. We're actually working on another. Well, NASA and other organizations are working on another drone project called Dragonfly that will actually send a drone type robot to Titan, not the one that Thanos is from, but from the moon of Titan around Saturn. And it's going to also fly around, look for pools of methane, potentially take samples of that, maybe find life there too, even life that could exist today.
That is absolutely fascinating. Yeah, I had been wondering that, and just thinking about how to even like test something like that is tough to even think. I guess just like certain vacuum like
Yeah,
chamber.
so they actually did it in a chamber that mimicked the atmosphere of Mars, and they strapped it in a way that it would behave based on the gravitational influence of Mars. So they actually really did a good job with truly simulating Mars here on Earth, which is really cool.
That is awesome. Again, thank you so much, Derek, for coming out. I didn't see any other questions in the chat at the moment, so I want to just thank you one more time for talking about that and getting us all excited again about space. Do you have anything you wanted to plug before we head out?
Yeah, so again, I'm with the Emil Buehler Planetarium. People have asked me, when are we going to reopen? Right now, the hope, if everything keeps going, until the very end of this pandemic, hopefully we'll be getting back up and running in the fall. We're kind of ending our virtual program series, so we'll be taking a little break in the summer. But check us out at seminolestate.edu/planet for upcoming events. Hopefully in the fall, we'll be able to see you all again physically. We'll be able to set up some telescopes and things like that. But we'll also continue doing our virtual programs as well for those that we've actually had people from all around the world watch these things. So it'd be great to continue that. So again, seminolestate.edu/planet. And again, thank you so much for the Orange County Public Library for having me out today.
Oh, and we really appreciate you coming out for this event and the other great events you've worked with us before. They're all always fascinating. So thanks again. And thank you all for coming out tonight as well. I hope you all have a good night and stay safe, everyone.
Thanks for watching. Subscribe to our YouTube channel to be the first to find out when we have new fun and informative videos for you. Orange County Library System is your place to learn, grow, connect.